Okay, so we've got a review. Let me go ahead and get started here for a test. So we're going to do it over triangle segments, concurrency, inequalities, and mid-segment. All right. So you remember these. Triangle segments are PAMA on the left, and SECO is on the right. That's the points of concurrency. Okay, so P is what? Perpendicular bisectors. Okay, if you have three perpendicular bisectors, then that will create the concurrent point called a circumcenter, right? Okay, A, angle bisector. If you have three angle bisectors, they will create the point called an incenter. Okay, M, three medians, right? If you have, or if you have a median, then three medians will create the centroid, right? The point called the centroid. And then A is altitude. Three altitudes create the orthocenter. Okay, these are triangle segments. These are points of concurrency. Okay, so what is the name of the red line segment or line? It's an angle bisector, right? It bisected the angle and created two angles that are congruent as it left. Okay, so what is this red segment called? Yeah, it's a median. It goes down from the vertex and hits the middle. You can tell because it's got those congruent marks. Okay, is this the altitude or is this the perpendicular bisector? Yeah, it's got to be the altitude, right? It starts from there and goes down and makes a 90, and these parts aren't congruent. Now, these are. This one's congruent to this one, so this red line segment is the perpendicular bisector. This starts from the middle, and whenever it goes up, it makes a 90 as it leaves, so that's a perpendicular bisector. Okay, so now we're going to talk about points of concurrency. Okay, what is the name of this red point? Okay, it's an incenter. Why? Because it's made out of angle bisectors. Angle bisectors, incenter. Okay, all right, what's the name of this red point? Okay, these are three medians. Medians create a centroid. Okay, all right, this point is called, that's correct, it's an orthocenter created by making three altitudes create the orthocenter point. Okay, this point will be called, yes, a circumcenter. Yay. Okay, the circumcenter is made out of perpendicular bisectors. Okay, so which one gets the big circle? Of course, the circumcenter goes all the way around. Which one gets a small circle? Yeah, the incenter. Inside, incenter. Circumcenter goes all the way around the outside. Okay? All right. So, which point of concurrency is equidistant to all three vertices? Okay? That would be the circumcenter. All these red lines are the same length. Okay? And then next question, which point of concurrency has a circle around the outside? Well, of course, this one, the circumcenter. And the reason that it does is because the circumcenter is equidistant to all three sides. They're like radiuses or radii, right? This one, and this one are radiuses of a circle or radii of a circle. This is the center point called the circumcenter. Anyway, next, which point of concurrency is equidistant to all three sides? Okay. If you said incenter, you're correct. Okay. This one's the same length. All of these red lines are the same length to each side of the incenter. And you can tell it's an incenter. It's got the angle bisectors everywhere, right? Three angle bisectors. All right. Next question. Which point of concurrency has a circle around the inside or inscribed into the inside? Well, the incenter does, okay? Because that's how these line segments are all the same. They're radii as well, right? Okay, so my portables right here, you got Town East Mall over here, you got Wendy's over here, you got McDonald's over here. What kind of a point is my portable? Circumcenter, that's right, because it's equidistant to all three vertices, right? Okay, so question, what type of triangle segments would be used to find this circumcenter? What kind of triangle segments? Remember, it takes three of them to make a circumcenter? Okay, you would have perpendicular bisectors. Okay, this would be made out of perpendicular bisectors. You don't see them there because they're only referring to the three vertices that are equidistant from, or the circumcenter that's equidistant to the three vertices. Okay? Next. Okay? Centroids are broken up into 2/3 and 1/3. Okay? Each median. Okay? This is the short one, so that's 4, so this one is 8. Obviously, 2/3 is twice as big as 1/3, right? Because if you took 1/3 and multiplied by 2, you get 2/3, right? Okay, so that's 8 and 4. These are the easy ones. Okay, the short one here, so if that's 12, this one would be 6, right? And then if you had 10 here, that's the long one, so this one would be the short one, so it's half, so it'll be 5. Okay, now let's look at this one. AC all the way to here, the whole median is 27. Okay, so how would you find the short one, BC? Okay. Okay, 27 times 1/3. Okay, 27 times 1 is 27, divided by 3 is 9. So that one is 9. What do you think this one's going to be? Of course, double. It's going to be 18. If I needed to, I could have said 27 times 2/3 to get that one, but why do it? Okay, next. Okay, what if AC, the whole segment, was 15? What would X be? What would X be? Okay, now if AC is 15, then I can figure out the short one, right? AC, 15 times 1/3 is 5. Okay, so this one is 5. Then what would AB be without the 2x? Act like the 2x is not there. What is this going to be? Yeah, it's 10. This is 5, so this one's got to be 10. So if it's 2x and it's 10 for the same segment, then 2 times what would be 10? Yeah, 5. Okay, so x is going to be 5. Okay, very good. All right, so is it a triangle? You look at the three sides and see if it's a triangle. So you pick the biggest one, right? You add these two together and see if they're bigger than 7. If that's true, then yes, it makes a triangle. Okay, 2, 6, and 10, does that make a triangle? No. 2 plus 6 is not big enough to be bigger than 10. So those two sides wouldn't even reach if you had a 10 for a side. So that's a no. Okay, and then what if it's equal? You got an 11 and you got a 7 plus 4. Would that make a triangle? No, that's two straight lines. Okay, so you remember that? Okay, what if you're trying to find a range of the third sides that a triangle would make? Right, 2, 5. If you had 20, then 20 wouldn't work, right? So this one is the gimmick, okay, where you actually take 5 minus 2, the two numbers, and 5 plus 2, and you get 3, and you get 7, and then you plug them into this less than or equal to double inequality. Okay, so this is saying that all the answers are less than 7, and all of the answers are bigger than 3. So all the numbers in between 3 and 7 are good, like 4, 5, and 6, 3.2, 6.7. All those are good numbers for a third side for 2 and 5. Okay, but 3 is not good, and 7 is not good either. Okay, so all the numbers between 3 and 7 are good for the third side if 2 and 5 were the sides. Okay, 5 and 9, use the trick. 9 minus 5, 9 plus 5. Use 4 and 14, plug them into the equation. Everything bigger than 4 and smaller than 14 works to be the third side of the equation. Okay, now, smallest angle is going to be across from the smallest side. Which one's the smallest side? Well, 12. 12 is the smallest side. So on this side, the smallest angle is going to be angle R, right? Okay. The medium-sized angle, okay, would be across from the medium-sized side. So 14 is the medium side, right? So over there is the medium angle, angle A. And then the biggest angle is going to be across from the longest side. Longest side is 16, right? So over there is the largest angle, which is angle T, right? So shortest side is going to be across from what? Yeah, it's going to be across from the smallest angle. Here's the smallest angle, 26. So way over there is side TA or AT, whichever one you want to put. Okay, I put TA. Okay. medium side. Okay, that's going to be across from the medium-sized angle. So way over there is going to be RT, which is the medium side. Okay, now the longest side is going to be across from the biggest angle. Okay, so way over there is RA. There you go. All right, so that makes sense. Okay, which angle is largest? Okay, across from here, so it's A. Okay, which angle is smallest? Yeah, across from the 9, so it's C. So smallest to largest, C in A, right? Angle C, N, and A. Okay, now which side is the shortest? The one that's across from the 50, so AN, right? This one. Okay, side is the longest? Across from the 70, so it's got to be AC, right? And then longest to shortest, okay? This is the biggest, so the longest is AC, right? Okay, the medium is across from 60, right? So that would be CN, right? And then the smallest would have to be across from the 50, which is AN, right? Okay, last one, I think. Okay, mid-segment. Remember, it's a mid-segment if you've got these little congruent marks, because that's a midpoint. These congruent marks would make this a midpoint, and so if it has two midpoints, this is a mid-segment. Now, if that's true, then this one is half of this one, right? So if I wanted to set up an equation, I would have to do something special to make them equal so I could set them equal to each other. X plus 4 is not equal to 4x minus 4. So I would have to take this one and multiply it by 2. Now I could take this expression, set it equal to this expression, right? And then solve the problem, okay? You distribute 2x plus a, then you get rid of the smallest x, minus 2x. Then you get rid of the minus 4 by adding 4, right? That cancels. And then you've got 2x is equal to 12, divide by 2, and you got x is equal to 6. Very good. Okay, so that's what x is. Now, if I wanted AB, then I would act like the 2 wasn't there, and I would plug the 6 here. So 6 plus 4 is 10, right? AB is 10. All right, very nice. Okay, got to kill it now. I'm done. I got to kill this thing. How do I kill it? How do I kill it? Where'd it go? There it is. Okay, about dead, almost dead.